I'm Henry Segerman. This is the dLX by the Dice Lab. The Dice Lab is myself and Robert Fathauer. This is a 60-sided die with letters, and they're distributed in a way which is roughly the same as the distribution of letters in the English language. So you can use these to play a word search game. So roll your dice, and you hope that they don't go too far off shot, and you get some letters. So I have T, O, W, A, and I. So I can make the word tow, T-O-W. What else can I do? Wait, W-A-I-T. I don't know if there's any word with 5 letters I can make from that. Too many vowels. Let's try again, just see what happens. So this time I got T, D, O, S, and E. So dose, D-O-S-E. Set. There should be lots of things in here. Anyway, so you play this game, and maybe you get more points with more letters in your word. I've only got 5 dice here, but obviously with more dice you could try to make words with more letters. And I don't know how easy it is to tell exactly which letter is on top on the video, but it's pretty easy to see in person. This is the first injection molded die based on the Pentakis dodecahedron, one of the few possible fair die shapes with 60 sides. They're about the same size as our numerical D60, which is one of the other shapes, a deltoidal hexacontahedron. The name dLX is supposed to make you think of D60. The lex is spelt LX, which in Roman numerals is 60, the number of sides on the die. Except, of course, that we replace the numbers in D60 with the letters. And, of course, lex refers to lexicon or lexicographical, to do with words. And thanks to Julian Orbach for the very clever name. All right, let me tell you how we decided on the letter distribution. First off, here are the relative frequencies of English letters according to the book Cryptological Mathematics by Robert Edward Lewand. So the first thing one might try is to multiply these frequencies by 60, the number of faces we have, and round to integers. And luckily the integers we get sum to 60, which might not have happened. So we could have made a die like this, but for a word search game, it's not okay, in our opinion, that the letters K, J, X, and Q do not appear. Their frequencies are just too low. So we need to add in one face for each of these letters and reduce the number of faces for the more common letters. So how do we choose which letters to reduce? What we did is we looked at what the rounding did to move the frequencies away from what they should be. Here's that calculation. So these numbers are between negative 0.5 and positive 0.5, and the larger they are, the more the rounding sort of over-represented that letter. So in order of most over-represented, we should be reducing O, D, R, E, and U. And note that we cannot reduce V because there's already only one of them, so we end up with no V's if we reduce the V. We made one very small tweak. We reduced H instead of U, so the over-representations of these two letters are very close, and this gets us slightly closer to the correct proportion of vowels versus consonants, counting Y as a consonant. So here are the new over and under representations. Of course, J, Q, X, and Z are way over-represented, but no letter is horribly underrepresented. One last modification is that we give a free U after a Q, otherwise it will be rarely usable. And this doesn't make much of a difference to the U over-representation because Q is so rare. Finally, how did we decide where to put the letters on the die? This was mostly ad hoc. There wasn't some very clever balancing going on here. We tried to spread out multiple copies of each letter over the die, and we mostly avoided putting vowels next to each other. And we also attempted to avoid spelling out anything offensive if you just sort of read over the surface of the die. And there's also a secret message, which maybe you've noticed by now. So this is the dLX by the Dice Lab. Thanks for watching.